Hello everyone. So now I will show you how to use the Visual Studio in order to start working in C++ to start your first program, and I'll show you the main structure of the program, how to write some statements, identifying the variables, and running your program as well. So let's get started. First, I'll show you how to start the Visual Studio 2019. You can watch the previous video how to install the Visual Studio 2019, and I will link this here up into the corner of this video. First, after installing and finish everything, now let's start. This is the Visual Studio. You can search for it in your programs and then looking for Visual Studio. After locating the Visual Studio, you can start it right away. Next, I'll start a new project. To start a new project, you can go to the File menu here, then New, then you can start New Project. And here you have multiple options, and I will check this one. I will start with an empty project to start a console project. So click on this one, and we'll start here by clicking on the next button. And this is the first program. I'll start from scratch. If you have no idea about C++, don't worry, I will walk you through all the steps. Click next here, and then select your project name. I will name it lecture 1. And here, look at this. Here is the location where you can find your project. You can check here to browse, and you can change the direction. This is the default location, and I prefer to keep the default as well. Now create the project. Click create. Now we are creating the new project, waiting for the new project to start. Here is the main environment that you will be working on, and this is the Visual Studio. Here is the solution, and these are all the files related to your project. So here we have nothing yet. It's an empty project as we mentioned, and here is the window where your code will be appeared, and here underneath here is the messages that you can receive from the compiler. If there is any errors or any warnings, you can see them here in this window. Now let's get started, and let's start our project here. After creating the project, now we need to add source file. Here you can right click on this folder, source file, and then go to add, and then add item. So here we will select C++ file, which is .cpp. The extension of the file that we are going to do is CPP, C++. So this is for now. This is the name of your source, and you can name it. I will add this extension, source raf for Rafeeq. Now you can tell where it's located, and this is under the folder lecture, the project name, and this is the full path to your project. You can change if you want by browsing your computer and go to the right place. Click add here to add this source one. So here is the file, and here where we will write our code and our C++ statements. So double click. This is the project. It's an empty project, and I'll show you how to write your first program here in C++. First, we will start by some prerequisite statements that we'll need them in the future, and I'll talk about them later on. And one of the statements is the preprocessor directive, and this is start by the hashtag include, and so you can see the drop down list. You can click on it, or you can just write it by yourself. Then telling the compiler to include this file in our project. We will need this file in the next few minutes because we are going to use an instruction that is the cout, and this cout requires the using of the IO stream. So the cout will be the statement to print out any output you want into the screen. Next, we will do another required statement, which is using namespace, and here the namespace is the standard one. We will need this as well. Next, we will start by creating the main part. So here I'll start by creating the main piece of your program, and everything will be written inside this main method or main function. So the statement will be starting by int main and these parentheses and then begin and end. So this is a very important piece of your code, and the compiler will look for this main method to start executing your statements. So first here we started by int. This is representing the integer, short of integer. That means this main will return something integer. So don't worry about these details. You will learn about these in the future. So just do what I am doing now, and all of the coming project will have the main method, and you need to start your main. So the main where you will write your actual C++ statements. So if you want to implement any problem, you need to write your instructions, your commands inside the main. So here I am good now. I have the main. This is the main hub, and here is the beginning. These are the curly braces, and here is the begin, and this is, as you can see here, this is the begin, and this is the begin, and this is the end of the main. So from now on, when I say begin, I mean this curly brace, and when I say end, this is the end of the main. So this block will contain the code that you want to implement. One of the main things that you have to know when you start programming is to know the syntax of your language and the keywords. And I am teaching you from time to time some new keywords like the main. The main must be written like this one. You cannot use upper letters, small letters. You have to use exactly the same spelling, the same case, and the same formatting. This is one of the biggest mistakes that the students are doing. They are just writing, let's say, a full word here, integer, or the main with upper letter M, or replacing these parentheses with something else. Now, I'll teach you how to write your first statement, and this statement will be just to print something in the output screen. So the statement or the command that we can use, a C++ instruction that we can use in order to print something to the output screen, cout, and then this insertion operations, exactly the same. Okay, guys, do not replace them with anything else. This is required. And next, if you want to print a message, so use the double quotation marks here, double quotation, and here I will say welcome to my class. So after at the end of each C++ statement, there is a semicolon. This is the semicolon that you need to put at the end of each statement. If you want, you can click on this icon to save everything, or you click on here to save the source. And now we can start running this code, and we'll start seeing the output for the first time. So click on this button here at the top, and here are the messages that you can receive from the compiler. And this is the screen, the output screen. This is the console. and here you can see welcome to my class. Okay guys, so we just finished the cout statement, and this again to print out the message that you want. So enclose the message by the quotation mark, double quotation mark, and remember to use the semicolon after each statement. If you want to add more statements here, if I want to print something else, I will use again in a separate line, or even in this on the same line after the semicolon, I can print welcome to my class C++ and then semicolon as well. What do you think? Where the C++ will be printed? Is it in a new line or attached to the first statement? Pause, write your answer in the comment on YouTube below, and come back again. So let's run the code now and compare it to your answer. Run, and here we'll see. Welcome to my class C++. Why is this? All together in one line, even when we separate them in two lines here. Yes, you wrote two statements here, but you didn't order the compiler or the Visual Studio to move the cursor to a new line. So this is the thing. So whenever you use the cout, it will print it right away where the cursor is. So in order to move it to a new line, you have many options, and one of the options is by adding one more insertion statement here, and then we'll use the end line. This is you are commanding, you are ordering the compiler to print the statement and then to move to the next line. So let's run this again, and we'll see. Run. You will see that welcome to my class in a separate line, and then C++ in the next line. So again, the end L is the command that you can use in order to move the cursor to the next line, and this is how you want it to be. By the way, you can do both statements in the same line. So you can do this. Look at this here. I can do more than one thing to be printed in the same cout command. So cout, and this is the insertion operation, and then you have welcome to the class. This is the message that you want to display, and then there is another insertion operation, and then you have the end line, which will be moving the cursor to the next line, and then here is the other statement or other message that you want to display. So if we run this again, you will see the output here the same as the previous. No need for multiple statements. Okay guys, so now we will talk about variables. So sometimes we need to work on some values, processing the values, make some mathematical operations, and then display the output using the cout. So if you want to save your values, then you need variables to save them into your computer memory. Now if you want to work on some values and you want to save these values, you need to know about variables. So let's say if you want to save your grade or your score in your test, so you need a memory space to save it. So we will use a variable to refer to that memory place. So first you need to select a name based on some rules for the variables. First, let's say I want to save my first exam, C++ exam. So I will pick a name for the variable, and the variable name must start with character. a letter. So here I'll start by saying first test, referring to the first test. So what do you think? What kind of data you will save in the first time score? So I am assuming that this will be something like I am getting 90.5 out of 100. So what do you think? What is this kind of number? Is it an integer or floating point? So you have to decide. So you have to think about the scenario you are working on, what kind of data. So first step again is to pick a name for the variable. The variable name must start with a letter following by sequence of letters and or numbers. I can say first test 1. This is good. And I cannot start by a number. No numbers at the beginning of the variable name. So I'll share with you the list of the rules of how to select the identifier or the variable name. So again, one more rule: you cannot use some C++ keywords. You cannot use C++ keywords like main. The main is good, starting with M, with a letter, no special characters, and that's good, but the main is a reserved keyword. You might ask, how can I tell? You'll learn day by day all the list of the keywords, okay, of C++. So let's say that we have this one. So before we can use this variable that we just created, we need to declare that variable. We need to tell the computer what kind of data type or what are the data types that this variable can save. What is the actual data type? So we have a list of types. We have integer, int, we have float, double, character, string, and much more. So this one is float. This one is float, is a floating point, or you can say double. Double has bigger space. So let's say this is the float. So now I started by selecting the name based on the identifiers rules, and then the data type. I cannot use it without the data type, and then I can initialize it. So this is the initializing of that variable. One more thing, I can say the average will be initially 0, and the average has a data type. This is another variable, average. You see that? The average is variable name, and it's good so far. But there is a red underline telling you that there is something wrong. Can you tell what's wrong with this statement? Yes, the answer is because we used it before we declared it. So we need to identify what data type is this, the average. So while we are using the floating point, so float as well. So we are good now. You see that? So let's keep working on this one. If we have more than one grade, so we can do these things. So float, second test, and that's it. I can initialize it right away, or I can just declare the variable and set the value in a separate line, as you can see here, a value that you want. So here we have two things. I can do both of them in the same line as well. If let's say that I have float test 3, and I can initialize it to 78.0, and comma here. Look at this. I am using comma, not semicolon, because I am not finishing this statement yet. I want to declare more than one variable within the same statement. Test 4 equals 88.7. So look at this here. I can do this instead. So look at this. I can do what? I can declare two variables at the same time, initializing both or one of them, and then I'm ready to use them. Good. Now let's do some calculations, some operations. We need to find the average of these things. Now I want to use the average variable, and then I will say equals to average equals to what? To the first test plus second test. So let me correct here. Let me correct this one. Test. So here test 1, 2, and then test 3 plus test 4. All together, add them up, and then enclose them by the parentheses to divide all of them by the number of tests, which is 4 here, and remember to add a semicolon at the end. So now I have the average, and here is the statement that we already did, and I want another statement here, and I will say your average for this class is, and then look at this here. This is the message. After the message, I want to add one more insertion operation because I'm planning to print something else after this message, which is the average. The average that we just calculated is saved under this variable, so I'm going to use this variable to be displayed. So average, but this time I didn't use the double quotation because I don't want to print the keyword or the word average. I want to print the value of this variable. You see that? So I am going to print the value. The compiler will check, do I have a variable named average? Yes, I do. What is the value? It will be displayed. Now my question, where this statement will be printed? Is it on the same line of the C++ here, or on a separate line? Yes, your answer is correct. It will be on the same line. What I have to do in order to print it in a separate line, here on the statement above, I can add the end line to move the cursor to a new line, so the next statement will be printed in a new line. So this is a good review for you. Now let's run and let's check the results. Your average for this class is, here is this grade. It's good grade so far. You can improve it, and that is cool so far. Good job, guys. So this is welcome to my class, and there is new line C++, there is new line, and this is the thing all together, the message, the average, and the value of the average will be displayed here, right? So here I'll show you more examples of variables data types. We worked on float, and we have other data types like integer. So if you have your age, integer age, and here I can say your age is 20. Okay, so the data type of the variable age is 20. By the way, you can use the underscore. This is acceptable in C++. And look at this. Integer age equal 30. What do you think? Is this age, the first age is the same as the second age? No, because I'm using different case. Here I am using upper letter and here small letter a, and Java is case sensitive. So age with lower letter a is not the same as age with upper letter a. Remember this thing. So again, one more thing. If you say that, let's get rid of this statement. If you say age now equals to 40, and you want to print the age now, what do you think the age is? What do you think the age value is? Is it 20 or 40? The answer is 40. It's the last update. You are updating the value. Initially it's 20 and then you set it to 40, so the updated one will be saved and you will override the previous value. Remember this as well. More variables or more data types. We have character. If you want to save like your grade is, let's say, B. So B is one character. So grade is the variable name, and here I am saying that the grade is of type character. You can save just one character, 8 bits. One character, either A, B, C, or any other letters. One. And look at this. I am using here single quotation. It's enclosed under single quotation. This is telling that this is one character and this is good to go. So these are the things. If you have, let's say, name, what do you think? What's the data type of the name? What is the data type of name? There is an error here because we didn't identify, we didn't declare the data type. So what is the data type? What do you think of the name? Is it character? Is it integer? No, none of them. It's a string. Look at it, string. To use a string, sometimes you need to include the header file hash include string to use the string. So we have now float, integers, character, and we have string. Good. We have other data types like Boolean to save either a value of true or false, yes or no, like pass. So you can say true or false, pass, true or false. So you can do this as well. So the Boolean is just to save one of two values, either true or false, Boolean. So we have now integer, float, character, string, Boolean. So for each case, there is the right data type. You have to read your case, read the problem, analyze the problem, and then go from there to identify which variables you need, and then what is the data type of the variables, and so on. By the way, there is a good video, I will link it here up, about how to start working on a project, how to analyze the problem, how to overcome some programming difficulties. So I'm encouraging you to watch this video as well. We'll talk about two main things. The first is how to accept input from the user using cin, and second thing is how to use the if statement with some examples. I'll show you how to accept input from the users. So last time we worked on data types and printing out some results or some messages on the black screen. Today we'll keep working based on what we learned last lesson, and now I'll show you how to accept input. So the command to accept input from the user is cin. If you remember last time we talked about the cout to print something on the screen, but now cin. Both of them need the IO stream that we included here at the top. So input output stream. So now cout, let's display a message and let's say please enter your name. Okay, now if you want to accept the name, so line number 7 is just to display a message to tell what the user should enter, but here is the instruction cin. This is the instruction to accept input, and now we want to accept the name. But as you learned last time, that before we use any variable name, we have to declare that variable. So I will go here and I will say that this is a string and it's a name, right? So this is the name that we want to accept. Here we need a semicolon and to fix this out. Now if I run this code, you will see that the screen will show the message that we displayed, that we printed, please enter your name, and now I will enter my name here. I'm done. So it's better to improve that code and print what the user has entered, and I will print the name here. So I am printing what is the value of the name using cout. If you want to print it in a new line, this is a good review for you, so just say end line to move the cursor to the new line. So now hit on this button to run your code, and here will be the black screen will be displayed, and now this is the name, Rafeeq, and here I can see the name that I just entered has been printed here. I'm done. I go back. So this is the thing. Make sure to watch the video to the end. There are a lot of good information that I will share with you. Now let's do some additional steps, and here I'll define some information about a student. Let's say that the name is the name of a student, and here we want to define the score. We want here to define the score or the scores of the user. So we have, let's say, score 1, score 2, and score 3. These are the 3 scores that we are intending to accept from the user. So at the end, do not forget to type the semicolon at the end of each statement. Now, after that, here in between, I will accept the 3 scores from the user. So I will use one statement, the cin again, to accept score 1, and then the second score as well. If you can see, I can do all in one statement, or you can use a cin for each variable. So I prefer for this scenario to do all of them together and do the same operation, the extraction operation, and score 3. You might ask why we didn't do this at the same line, the same instruction, the same command. Yes, you can do all of them at the same time. So the first enter will be equals to the score 1, the score 2 will be the second entered value, and the third one will be the third. After that, I can here print something and line to move to new, and L to move to a new place. And here you can do with or without the spaces, but here to be more readable. So cout, move to a new line, and then I will print the score 1 that the user entered, score 2, and score 3. So we have all of them together. Let's try this one, run. And now the name, Rafeeq. Now I didn't print any message. It's much better to display a message to the user asking the user to enter the scores. But let's say the first score is 60. The second score is 78. And the third is 80. So at the end, I can see the grades all together, no spaces, because we didn't order the compiler to keep spaces. So to improve this, we need some spaces. I can do here spaces as this. We can do the spaces and the same between each variable. So now if I repeat the same process, I can see the spaces. One more thing, I can do a message here asking the user to enter the grade. Enter your grades. Semicolon at the end, and we'll be good to go. So run. Here's the first name, the grades 40, 80, 90. Here are the grades. This is the name, and I have all the things. So here you learned how to use the cin to accept input from the user and much more details. Great. Now let's move on and improve this project. And now if I want to calculate the average of the scores, so I will define a new variable, name average, and I can initialize it to 0. Next, I'll do the calculations here. After entering the values in line 16, I'll do the calculations. Average equals to score 1 plus score 2 plus score 3. Remember, there is there are no spaces in the variables names. The variable name has no spaces. Now, enclosing this by parentheses to divide all of these, the summation by 3 to find the average. Now I can print here. You can do it in the same line, in line 18, or you can do it in a separate line. I will do end L to move to a new line, and then I can do the average. I can print a message. The average is, and then another insertion operator plus the name of the average, the variable, and semicolon. So here I'll see the results. Now run. Rafeeq, the grades 70, 80, 91. Here are the grades, and this is the average. You see that the average is a float, and we can see the results. Now I'll show you how to use some control statements and how to make some decisions. So what if I want to know if that student passed the class or not? So we need to use one of the control statements, and here in this example I'll show you the if statement. So here I'll ask if is a reserved word, so add this to your dictionary. C++ reserved word, a keyword. And here the parentheses, and now I will say if the average equals, look at this equal. This is the Boolean expression, Boolean equivalent. I am asking if average equals to something, or I can say if the average is greater than or equal to 60. So if this is correct, then I can print that you pass. If not, if I want to consider that, then I will use the statement else, means otherwise, then I will print fail. That means if the grade is less than 60, then the else will be triggered. So one of these two statements will be executed. If this condition is true, then the first statement will be executed, otherwise the second one will be executed. If we have more than one statement that we want to execute while the condition is true, then we need to use the brackets here, the curly braces, and list all the information. I can say that the name of the user and then the results. So name and results, both of them will be executed in case of the average is greater than or equal to 60. Otherwise, I have just one statement. So if you have one statement, there is no need to use the braces. It's optional, but with more than one, you need to use the braces. Now let's run and let's check. Here the name, the grades, 78, 88, 60. Now the grades, the average, and you can see it's pass, name pass. So to make it better looks, then we need to add some spaces or lines. So here I will add end L to move to new line. Here we can do the same. You can use, by the way, you can use this control statement to do the same thing as end line. You see that? This is the command, the control N, to move to new line. So again, Rafeeq, and this is the 70, 80, let's say 60, you can see that this is the name, these are the grades, the average, and then the name again, and it's pass. So here we didn't leave any space, so we can do this, moving some spaces, and we will be done. In this part, I'll show you more examples of using the if statement. So based on what we did so far, we want now to find out which score is the highest score that that user gets. So first, I will start by writing some comments. And as you know, to write a comment, we can use this these characters, and this is a comment. So here I can see, I can write to find the highest score. So this line will not be compiled, the compiler will ignore it, it's just for your comments, just to tell what's going on. And it's very recommended, and this is one of the standards that you have to be familiar with. If you have more than one line, so you can use these symbols and you can write the different information, different lines, many lines in between these two symbols. But now let's keep it short. We have just this one statement. Now I want to say if, again if statement, and I want to compare each score with the other two scores. So we have many ways, and I will do the shortest way. So score 1, if the score 1 is greater than, this is the operator to use to compare it to the others, greater than score 2, and means we need to satisfy both of the things. Score 1, again I have to repeat that, score 1 is greater than score 3. So in case that both of the conditions, this is the first condition and the second condition, if both of them are true, then can you tell guys which one is the highest score now? So score 1 is greater than 2, score 1 is greater than 3. If this is the case, the compiler will check the numbers. If that, then I can print this statement. I can print score 1. This is the score that is the highest. Now else, otherwise, I can say again, else if score 2 is greater than score 1 and greater than score 3. Then now you can say that the answer will be score 2. The same thing for the third one. So I'll copy, paste, else, or I can do without else. You can just keep them else. If this is false, the previous one, then I will compare the 3 to 1 and the 3 to score 2. If this is the case, then score 3 is the highest number. So now let's run the code again. And here is the name, the grades, and now this is the name, the grades, the average, pass, and which grade is the highest. Here is the highest grade, 70. You see that? It's the highest grade. So we can do whatever we want. Now, you can do this in many other ways, but this is one of the ways. When you are done at the end, you can write return 0. This is required for the main. Main is returning something, and we said that this is an integer, and the 0 is matching that. It's integer, returning that. Now, the bonus for you here, look at this. If I say my name is Rafeeq al-Hashimi, and there is a space here. So look at this. Here, my name is just Rafeeq without the last name. Why is this? This because that the CN here in line 13 is accepting all the characters before the space. When there is a space, then the CN will be terminated, and everything after the space will be ignored. So how to overcome this and how to accept a name with two parts separated by a space? To do this, we need to use another way, use another instruction to accept input if it is a string. And this will be get line parentheses CN comma the name, the variable. But this one, this command, needs another header file to be included at the top, which is include string. We need include string, and this will be good. So the required header for the get line is this, include string. And the purpose of this line is to accept a string that has some spaces. So let's repeat this statement. Let's run this code again. Rafeeq al-Hashimi. There is a space, enter the grades. 80, 90, 80, let's say 84, and you see that, look at this, here's the full name now. So again, get line to accept input with spaces. This is good for strings. I'll share with you how to use the for counters, nested for counters, and some examples to illustrate those concepts. So here in this example, I will show you how to use the for counter, and the idea here is to find the factorial of a number. So first, let's start by declaring some variables, and then we'll go from there. And one of the variables is integer. F is the factorial, and we'll initialize it to 1. Here F will save the factorial at the end. The main format of the for counter is by starting using the keyword for, then these parentheses, and then we'll declare a variable that we will use in order to move from one number to the end of the for counter. So here the number of this counter will start from 1. I will repeat from 1 to I is less than or equal to the number that we want to factorial of. So here, let's say the number that we want to find the factorial for is number 4, and so that's why I will do the counter from 1 to 4. And here, next semicolon, look at this, we are using semicolons. I will do the increment, how much this counter will be incremented. So it will be started with I equals 1, and then will be incremented by 1 each round, each iteration. Here I will use the f that I just declared and will say the new f equals to the old f times I, which is the counter here. Now let's try and test. So I will print this message: factorial of 4 equals to f, which is the final result. So let's start and test this one here. Here is the result. 4, the factorial of 4 is 24. So let's try doing another number. If you want to find the factorial for number 3, so here we'll run it again, and the number of 3 will be 6. So based on this one, for 3, that means 3 factorial means 1 times 2 times 3. So as you can see here, we have some numbers starting from 1 to the destination here, the target, which is 3. So the counter for I is representing these numbers, generating these numbers, and each time we are accumulating the results and save them all together in the F here. Now let's do another example based on what we have achieved so far. So I want now to find this series, the result of this series, where y equals to 1 factorial divided by 1 plus 2 factorial divided by 2 plus 3 factorial divided by 3. So we want to do this equation, this series, and we'll take advantage of the factorial that we just finished, and then we'll divide the factorial by the number here 1. So 1 factorial divided by 1, 2 factorial by 2, and so on. So we'll take advantage of the counters, the 4 counters, and what we achieved, and here we will improve this code as follows. So first I will declare a variable named y and initialize it to 0 here, and next I will start doing the equation, this one. So here in each term, here in each item, we have 2 things. We need to do the factorial and divide them by the number 1. So let's say that here is the factorial, this one is the factorial part. Now each item here needs the factorial. So that's why I will use another 4 counter, and here I will say j equals from 1 to j less than or equal 3, because we want to do the series of 1, 2, 3 as it's mentioned above. And here the increment will be by 1 as well. Now here, as you can see, we have 2 4 counters, and if you have 2 4 counters, one is following the other, this is called as a nested 4 counter, nested one. Now instead of finding the factorial for number 3 as we started with in the previous example, here I will do the factorial for the first term, which is 1, and the second term, which is 2, and the third term, which is 3. So these numbers 1, 2, 3 will be generated by the j counter. The I counter, the purpose of I counter is to find the factorial of each item of the j factorial. So that's why I will say that the I will be equal 1 to j to this one. Now let's get rid of this one. We don't need the factorial anymore. We want just to find the results. So we need the brackets here. We need the brackets to repeat this process for each round of the j counter. So we need to repeat it for this item, and the third item as well. So that's why each round from the J will repeat the process of I will walk from 1 to the current number of J, the current value of J, and finding the factorial. Next, after finding the factorial, we need to accumulate the results and save them in the Y variable that we declared. So back to the series, we need the factorial, which already we generated with F in the line above, 14, and dividing them by 1, and the 1 is generated by the J counter, which is here. So in order to accumulate the values, the old plus the new one, we need to do this. Y, the new Y equals the old Y plus F over J. Okay. At the end, when we are done, let's just print the, so here and L. One more thing, we need to reset the factorial each time we are moving to the next term here, as you can see. So here the result is 4. The result of this series is 4, and this is the target. So this is for now, and I hope you learned how to use the nested for counters as we saw here. So each round from the J counter will repeat all the rounds of the I counters, and these are very similar to the watch, your watch. We have the minutes and hours. So each round from the hours needs the 60 minutes to be passed as well. So these are the two things. So the J will represent the hours, and I is similar to the minutes. We will be talking about a very important subject, which is the array. You'll need to know about the arrays, and this will be very helpful for you for the coming projects. So stay tuned. We'll be talking about one-dimensional array and how to pass the array to the methods. So now this is a new project, and I'm going to show you how to declare and use the arrays. We'll be talking about one-dimensional array, and as you know, the array is a variable that can store multiple values, and those values are of the same data type. So in the past, you were using just regular variables like this one, integer index equals to 0. So the index of type integer can save just one element or one value, which is, as we initialize it here, 0, and we can update it. So if we say index equal 9, then the index now is 9, is overwriting the old value. But if we want to save both of these values and more values that we want, such an example, your scores, we don't want to overwrite the scores, we want to save the score of your first test, second test, and so on, and keep them safe. So that's why we need to use the arrays. So here I'll show you how to start declaring an array, and let's say that the array is of type integer, double, character, whatever you want. But here I am saying that this is an array of scores, and this array is of size, let's say 3. So here I am declaring a new array of type integer, and the size of this array is 3, which represent the 3 grades that you have, or the three tests that you have. So now after declaring the array, and here is how to declare it, remember to use these brackets, these square brackets, and do not use any other kinds of brackets. This is the syntax of C++. Now let's start by filling the array with some elements. So remember that the array has an index, and the index is representing the location. So look at here. So if we want to declare this array, and as you know, this array is of type integer, so here we have the array, and this is the array, one-dimensional array that has 3 elements. And here the index, the first index is 0. We start with 0, which represent the first location, and then going up, this is number 1 and this is number 2. So the name of the array is here scores, and the size is 3, as you can see is 3, but the index is starting by 0 to the size -1, 3 minus 1, which is 2. And here we are going to save some elements inside. So we can save the first grade, which is 70, the second grade, you are progressing well, 90, and then you get 95. Good job, guys. So these are the things. So let's start here and let's do the code. Now here I declared it here, and next I want to start filling the array. So we have many ways to fill the array, either by initializing the array right away, or I can accept input from the user. I can fill it with some data by doing some calculations. So if you want to initialize it, then you can go ahead and use these curly braces, and here you can say 70, 90, and 95. This is one way. Or you can fill it by using the cin to accept input from the keyboard, from the user, and then fill them with different things, which I prefer. And here let's do it as simple as possible. And now we want to print the results, or print these grades, just we want to print them. So we need to say I want to print 1 by 1. So I want to print the first element of the array, which has the index 0, the second one which has index 1 and 2. So I'll use a for counter to go from 0 here to the size -1, which is 2. So that's why I will say index equals 0, and the index is less than 3, and here the index ++. And now next I will say cout, and here we'll print the array, which it is scores, the array name scores, and then we need these brackets and the index that we have. So if the index is 0, then it will print scores of 0. To fix this problem, the cout, we need here to write using name space, and here a standard, and this will fix the problem. Okay. Now if you want to leave some spaces between the numbers, then I will do some spaces here, and I will use the insertion operation. Now run. So this is the thing. So we initialize it, and second we are doing this to print them out. Now if we want to do some processing on the array, such as sorting the array, I want to sort the array, but this one is already sorted, so I can change here some numbers. I will say here 70, here 60, and here 65. Okay, so these are the numbers, and I want to sort them. So here in order to sort the array, I want to do the following. Look at this here. I want to compare the first element here the 70 with the rest of the elements in my array. So I will set a pointer here to point to the first element, and I have another pointer to compare each one of the element to the rest of the array until the end. So I will name this one as the index I, and here as the j, the second one. So that's why the I will start from 0, as you can tell, and the j will be equal I plus 1, which is here 1. Always j is preceding the I, or j equals to the current position of I plus 1. So I'll compare 90 to 70 and swap them if we want to change the positions, if the one is smaller than the other or bigger, and then moving to the next one here. So we can move the j to be here, and the j now is 2. So that's why we can compare the first one to the rest of the array, the first, the second element, and the third element. After we find the smallest element, will be moved to the first place. So this is to sort the array in an ascending order, and then we'll update the I to be pointing to the second element because the first is already sorted, and we will compare it to the rest of the array. So this is the scenario, and let's go ahead and do the things. So here I will use the for counter here, the index, the first one, and the for counter j. So I will start from 0 to not 3 to 2, because the j will be, if the I is 2, then you know the j will be I plus 1 to start from the next place of the index. Lose them. So here I will use a new variable temp to save the first index, the first element of the array at the first one, and then this one will be available to save the scores of the second element, which is represented by j. And here the third step is that we can say that the scores of j will be equal what we saved at the beginning, which is the temp. So this is how to swap the elements. Okay. So imagine that you have two cups, one filled with water and the second one is filled with orange juice. So how to swap them? You need a third cup to move the water to the empty cup, and the empty cup here is represented by the temp, and then moving the content of the second cup that has orange to the first one, which is empty, and then moving back the temp, or moving the extra cup back to the second cup. And this is what is going behind the scenes, similar to this example. And now let's go ahead, after swapping all the elements one by one, and let's go ahead and print the array again. So I'll copy this and paste it here and run the result. Run again, and you can see here. So let me do something else. Let me print a new line to separate the two arrays before and after. So here before sorting, and here after sorting. So it's already sorted. You can see here it's the array is sorting in ascending order. My question for you guys, and I want you to write down in the comments below on YouTube what to do in order to sort them in descending order. Write this down. Let's see what's your answer. The last part is that we can do the sorting in a function. So we can do a function that is doing the job for us. So if we want to sort more than one array, then we don't have to repeat all these statements. We have a lot of statements here, so we will write them in a function, and whenever we want to sort any array, if we have one array, 2, 3, 5 arrays, just call the function. And this is the benefit of using functions to minimize your code, to improve your structure, and so on. So let's do it together. So I will cut this code and I will create a method here. So the method will be as follows: returning nothing, and the method name sort. And here, in order to sort an array, we need to pass the pointer to the array or the name of the array. Look at this: scores, and just the brackets without saying anything. And then we need the size of the array as well. So here is a method. This is the method to sort. In order to send the array from the main, which we will be doing shortly, we need to receive it, and this is the way to receive it. This is very important to know: the data type, the array name, and just brackets without writing anything. Here we are sending just the first element, and this is the size, going from the first to the size. And here I will do paste view the things that we just mentioned. So that's it. And now here I will call the method that we have here. We call it sort, and we need to pass the array. Pay attention to this point: scores. This is the way how to pass the array to a method. Just the name of the array without the brackets. Do not use the brackets. But when you received it here in the header of the method or the header of the function, you need to use the brackets. This is very important. And let's do this. Let's run, and we'll see the result is the same, but now the code is more professional, more structured. And if we have more than one array, then all what we need to do is calling the method and just adding one line like this one. See that? Just one line and you'll be good. So if you have more than one array, without the methods, you need to repeat all of these. So write down your comments if you need me to cover anything in the future. Today we'll be talking about a very, very important subject in C++, which is the pointers. Okay, now so let's work on pointers, how to declare a pointer, how to initialize it, and doing some operations on the pointers in addition to some examples. So let's start by creating or defining a new variable. It's a regular variable that has the value of 9. And k is, look at this, we need to use this operator, which is the address of operator, and then the variable that we want. So this is the first thing to learn in this video. Run, and you can say that the address of k is this. So this is assigned by the operating system, and this is the address in hexadecimal system. Now, let's do another one. So what I want to do is to print the address of the second variable j is j address of j. You see that? So here is the address. So run it again, and here you can see both addresses. The first address of K, it's saved in somewhere into the memory, and the J is saved in a different place in the memory. Now, in order to work with the addresses, so you need to know about the pointers, and the pointers are very important subject, and it's one of the most important thing that distinguish C++ from other languages. So by the pointers we can save addresses into those pointers and to do some operations on those addresses. So now let's start by declaring a new pointer. So let's say we want a pointer of type integer, so you can change the data type based on what you are intending to save into that address. And here I am going to use the pointer of type integer, and I name it as p, and you can do it in this way. This pointer has not initialized yet, so we cannot work on it. That will cause some problems and some errors, and in order to start working on that, you can do either assign it to a null value or assign it to an address of a variable. Remember that you cannot assign an address right away. The addresses are operated and managed by the operating system. So here I can say that the P is pointing to the address, you know this operator now, pointing to the address of K. So P is saving the address of K, and that address K has some values in it, which is the 9. So here, look at this, and now I can see the address that P is pointing to is P. So let's see what is inside that pointer. Run, and here you can see that K has this address, and now P is pointing to the same address of K, because here we set that P equals to the address of K. If you change the content of P, the K will be affected. Let's see this one. So now if I want to change the value that the address saved in P need to be changed, so I will say that the content of that address, the content of the address saved in P equals 55. Okay, and now I'll print those values again. Copy here. Okay, let's run it here. I want to add the value of K is K. Let's see. Run. So the address of K is this one, and the pointer P is pointing to the same address. The content, look at this, content of K is 55, because we did change the content of P. If we change this one, the K will be affected. So the K now is 55. We are updating it through using the pointers. The address of K is this one, which is the same, still the same. We didn't change the address. That means that both of the address of the K and the P pointer are pointing to the same memory location. If we change the value of that memory location, both of those items will be updated, the pointer and the K. Now if you want to just increment the value of the K by 1 using the pointers, we can do this one. Look at this here. Now here I did what? Here I am using the parentheses because the priorities of the operations. So here the content of P, I am giving the highest priority to this pointer, to the content of the pointer, which is 55, incremented by 1. Now let's print that value. I'm using this operator to print the content of that address pointed by the P. So let's see, is this affecting the result? Will we get 55 or 56? What do you think? Let's check. Here, look at this. 56 has been updated. If I print the K as well here, run. K is this, and here is the P pointing to the address of K. The K value initially is after the first update, after line 15 is 55, and the address of the K is the same. And now look at this. Both of them, the results of this operation 18 is 56, and this will affect the K, which is 56 as well, because as we mentioned, both of them pointing to the same memory location. We have a new subject, which is the object-oriented programming, which is an excellent way of writing your project. So there are a lot of benefits of using object-oriented programming method, and this will be covered in this video. Today we will be talking about object-oriented programming, and we'll cover this concept. We'll talk about the classes, data members, function members, and the access specifiers. So let's jump into the Visual Studio and let's start with an example to demonstrate this concept. So here I just started a new project, and object-oriented, as you know, is a method of writing a program. We were working on the previous project using another way of writing programs. So we were using what is known as procedural programming way. We'll reorganize the way of writing our programs in an object-oriented way. So we have objects, classes, and we will work on those. So let's start by what is a class. The class is a blueprint that you will be designed for the first time, and then we can get copies from this class, and these copies known as objects. So imagine that we have a student and we want to save some information about that student. So we will design a class that has both of the data and the methods or the functions all together under one piece, under one thing, which is the class. So the class here will start by writing the keyword class, and here student, and then we have the begin of the class and the end of the class, ending by semicolon. Remember this is very important. At the end of each class there is a semicolon. So here is the first class that you can design, and this is the name of the class that we started with. So the class has two main parts: the data members, the attributes of any student, and the functions or the methods that we can work on these data members. So by default, all the data members or all the members of the class in general are private. That means no one can access these members from outside the class. Everything will be inside the class. So let's take an example. So the student has name. So this is the first attribute, the first data member. Okay? And the student has ID as well. The student has age. The student has scores, score 1, score, let's say 2, score 3. So we have 3 scores here. The student has average as well, and we can add as much as we want. So these are the data members. By default, all the members of the class are private. So you can do like this, or you can just write private colon. So this is an optional one. You can write the keyword private or leave it without. So in both cases, it will be considered as private. But if you want to make some of them as public, you have to write the keyword public, and anything underneath, under the public keyword, will be accessible from outside the class. So that means you can access these new variables or functions from the main or other functions or methods in your project. So here I will do the first method here. Usually the methods are public, so we can do the functions private and we can do them as public, but most of the time the methods are public, and most of the time the data members are private, but we can do whatever you want based on your design. So here I will start by the first function that is a public function that is allowed to access the private member. So here I will say that void, I will say a method set name. So this is a method, and this method is a public method that is returning void nothing and accepting string n, which is the name that we'll be sending from the main method. So here, as you can see, we have all together the data members and the functions are integrated or are listed inside the same class. So this class contains all the details related to each other. Now here in this method, I will say that the name of the student will be equal to n that we are providing here. So the name that will be provided here will be saved in the right place in the name here of the class. So this is the first function, and you can keep doing that. This is known as a setter, set method to set a value to your data members. So I will do all the others, and you can just watch me doing this. Now we finished the setters to set the values, and now we will be doing another another set of methods to retrieve the data, retrieve the values of these attributes. So we will do something known as getters, get method. So here I will do string get name. This will retrieve the name. Okay, so because this method is a public method that can be accessed from the outside, and this method has the privilege, has the right to access any private member, because this method is inside the class that has the right to access the private member. So that's why I will do return, and this is all what this method can do. So just returning the name. I will do the rest for you guys. So we finished those. We have to do a getter for each of the values, because as you know, we can return just one value. So at the end, we want to calculate the average, get average, of those scores, and here we can write something else. We can write return score 1 plus score 2 plus score 3 and divided by 3, but let's add some extra parentheses, and here is the result will be. Now we are done, and let's try using the class that we just generated. So this class will be similar to a new data type that you will be able to use, and it's named student. This is the blueprint, and every instance or every object of this class will have the same information. So let's say here student std1, this is the first object, and this is one of the things. So std1 has age, name, average, scores, and so all the other members of the class. If you want to add one more student, this is the second student. So let's get started. So here I will say std1, the first student, the first object, dot set. I want to set the name of that student, and here is the first student's name. See that? std1 dot set age, and we can set the age of this student 23, for example, and std1 dot set, and here we can set the scores. We need to pass all the scores together: 70, 65, 90. See that? So we are sending that. The cout to print it out, but here I will do std all the time. Start with the object dot the function that you want. So you have all the list of the methods that we created, so we can retrieve the age, average, and so on. So I want just to retrieve the average, and remember, this is the way of writing it, some spaces, and you will see that the results. So here let's run, and you can see this is the average of the scores that we entered. See that? So it's calculated and retrieved by the get average. So you can do the other information. Let's say I want to print the student name, std1 dot get, remember the getter, get name, to retrieve the name of the student and then the average of the student. Run, and here is the student and his average. Good. So this is the first one. You can do the same thing for student 2, std2 dot, you can do the same, set name, set age, and so on. So you can do the same things for the other part. So this is the first part, and in the second part of this lecture will be about constructors and destructors as well. This is part 2, talking about object-oriented programming, and we'll be focusing on constructors and destructors. So in this video, I'll talk about classes, constructors, and destructors. So what are the constructors and destructors, and how to use them, and what are the benefits of using them. So let's start. Here we will keep working on the same project that we did last time. Here we have a class named student, and we have some private members and public members, as well as we have the main method that we created two objects, student 1 and student 2 of type student, and we initialize, we set some values, and we printed some results. So you can go back and watch that video. We will keep working on that. We'll go back to the class, and we will add something known as a constructor. Usually the constructor is written in the public section, and here can be accessed from everywhere. So the constructor is mainly used to create and initialize the objects. So here, in order to add a constructor to your class, you need to write the constructor, which is similar to a function but has exactly the same name as the class name. So what is the class name here? It's student. So that's why the constructor will be like this, student, and that's it. So here is the constructor. So again, this will be written implicitly if you didn't write it by yourself. And the main thing, as we mentioned, is to initialize the variables. So here we can give an initial value for all of our data members. We can set the ID to 0, and we can set the name, we can set the age. By default, the age at the college is 20, let's say, and we can set that the scores 1 equals score 2, score 3, and equals to 0 if you want. And here the average as well equals to 0 to just initialize them. So this is a constructor. It's similar to a function. It's member in the class, and this is called as a default constructor because it has nothing here, no arguments here inside the parentheses. So this is the default one, and we just did the initialization. So to see when this will be invoked, I will just print a message here to show us when this will be invoked. Default constructor. Okay, so this is the thing. And here, let me run the program. I did not change anything in the main. We have 2 objects, and let's run it here. And let's see the results. Look at this. We have 2 messages have been printed. This is the default, this is the default. And this is a proof that there is a constructor for each object. So we have 2 objects here, as you can see. So student 1 invoked the constructor, and student 2 invoked the second constructor. So this can tell you that the constructor is triggered and invoked right away when you create a new object. If you have a third one, let's say std3, and run the code again, you'll see 3 times that the message has been printed. You see that? So for each object there is a constructor, and it will be invoked right away when you create the object. Now, so to write a constructor, we have, as we mentioned, we have to write exactly the same name. And by the way, the constructor returns nothing. So do not write anything in front of the constructor. Do not write void or integer. It's nothing. There is nothing. Just the name and then the parentheses and the values or the messages that you want. Now, there is something known as overloading the constructor. So we can have more than one constructor in the class, but only one constructor will be triggered at the same time. Only one, nothing more. So here, let me show you. I have another constructor, but this time this constructor will accept some values, string n and integer id, integer age, and so on. So let's do this thing. So here we have another constructor that is accepting 3 arguments. So here I will say that the name equals n, that the id equals id 1 to id 1, and here the last one is the age equals to age 1. Write a message. This is the overloaded constructor. Again, to call the constructor, we need the name of the student and then the ID, and then the age, let's say 23. So this is matching the exact same parameters or arguments that we have in our constructor. 3 arguments, string, integer, integer, and these are the things. So let's run the code again and we'll see. Look at this. The first class, the first object, std1, calls the default constructor. The second one called the default constructor as well. The third one called the overloaded constructor. You see that one? So one of them will be invoked for each constructor. This is calling the default, and this is the conversion constructor, the overloaded constructor. You see that? So now I can here print the values, the current values of std3 dot get name, let's say, and let's see the name here. So run, and you can see, sorry, we missed this one. Run, and here is the name of the third object, Matt, that we get it from constructor as we passed it. Let's jump into the third one. We can do a third constructor that is accepting more arguments. So each constructor must be different than the previous one through using different data types or different number of arguments. So here I can say float score 1, float score 2, and float score 3. So you see that there are different arguments here, different than the other. So that's why the compiler can distinguish between one constructor and the other constructor. So you can fill that later on by assigning them to the right places. Now we are done with the constructors, and these are overloaded versions. Here in this example we have 3 constructors, but only one will be invoked at a time. Good. Now let's jump into another concept, which is the destructor. This destructor is used to delete that object from the memory and to release the space to be used later on. So the main thing, the destructor will be called automatically as well, and the name of the constructor will be the same, and this is the student, but we have a special here, a special character, which is the tilde here in front of the name of the destructor to distinguish between the constructor and destructor. So this is the destructor. So this is a destructor, and we have only just one destructor. We cannot overload the destructor. We have one destructor, and to destroy that object to release the memory space. So here all what we can do, or one of the things we can do, is to print a message to show us when this will be invoked. This is a destructor. You see that? So here I didn't change anything in the main, and I will run it again. Look at this. Destructor, 3 messages, because we have 3 objects. So when we finish, or when the scope of those objects terminated, then these destructors will be invoked. So at the right place. See that? So it depends on the scope of the destructor. So here we have again constructor and destructor. Here we have to fill all the information, but I will just comment these for later on. And here we have the destructor to destroy the object, and we can see that those will be invoked right away when we reach the end of the scope, when we finish using, or there is no need to keep them into the memory. So this is the second part, and I hope you learned something new. Subscribe and share, and goodbye. Thank you.